Right, the fundamental theorem of calculus and the definite integral. Wow, that's a big statement, isn't it? Fundamental theorem. What does it actually mean? Basically, just means these two things. An indefinite integral is where you just work out the value, or you just integrate that. Definite integral is where you integrate it between two particular points. So you're doing it between two definite points. Here, you're just doing it. Okay, so that's the difference. Definite between 2 points. Such a thing as signed area. If you think about it, A, which is this big triangle here, is above the line, positive, A1. A2 is below the line, negative. Easy enough. So if we work out the area of A1, so it's just base, which is 3, times height, which is 3, times a half, so 4.5. Area of A2, base, which is 1, height, which is 1, times a half. So the area of A1 and the area of A2, 4.5 and a half. So two ways we can look at it. We can look at the total area. So the total area of A1 plus A2 is 5, 4.5 plus a half. But the signed area is A1, take away A2, which is 4. So we've got to be really, really careful here, yeah, especially when we're doing our working out and we're showing what we're doing. So it's absolutely clear what we've gone, because we're going to do some tricky integration, and we don't want to mess up at the end by getting our signs wrong. So total area, add them, signed area, positive, take away the negative. So think about this one, positive, positive, negative, negative. So total area, add them all up, signed area, positive is the A1 and A3, so A1 and A3 are positive, A2 and A4 are negative. So here's some notation. So the definite integral, so if we work out the area from B to A, it gives us the signed area. So if we were to work out the area from here to here of this curve, it's going to be an annoying curve, isn't it? It's probably going to be a 1, or it could be a to the power of 5, or could even be some sort of sine or cos graph, couldn't it? We'd work out this would be from B to A, and it would give us the signed area. So it would give us this area. So when we do our integration, work it out between the two, we have to, it gives us this area. So if we wanted to work out the total area, we'd have to do it in 4 different bits. I'd have to work out the area from here to here, which would give me a positive answer. I'd have to work out the answer from here to here, which would give me a negative answer, but I would have to know that I would have to add it on. I'd work out the area from here to here, positive. I'd work out the area from here to here, be negative, but I have to remember it's positive and add those 4 together. So total area, do it in the different bits. Signed area, when you do this, it'll automatically work it out for you. We'll go through this loads more times, and as you do questions, you'll work that out for yourself. Signed area, definite integral. Fundamental theory of calculus, another big statement. They're chucking them out all over the place, aren't they? So what they're saying is, if we're working out the value from B to A, you have to work out the value at B and the value at A, which is what we just looked at. So what does this mean? So if we can evaluate the definite interval between 2 and 1, we work out the integral of x with respect to x, add a power, divide by that power, add c. And we're doing it when x is 2 and when x is 1. So when x is 2, we've got 2 squared over 2 plus c. And we're taking them away from each other because we're working out the area between them, 1 squared over 2. So that's going to be 4 over 2, isn't it? Which is going to be 2. That's going to be 1 over 2, which is a half. We've got 2, and we've got 2 minus a half, 3 over 2, 1.5. And look what happens. The c's always cancel out. The c's always cancel out. So when we're actually working out definite integrals, we can forget about c. We don't have to put our c. When we're doing our indefinite, we have to make sure we put in c. But when we're doing our definites, we don't have to worry about c because they cancel out. And there's just a cool little notation way of using it. They use the square brackets. So here we've already integrated, add a power, divide by power, and we're doing it from 2 to 1. So we work out the value when it's 2, the value when it's 1, and just take them away from each other. And of course we get the same answer. 3 over 2, 3 over 2. And that's, yeah, I'm sure you agree, that's a much better way to show you're working out than that is. So let's look at a few more examples, and we'll use our new notation. So add a power, divide by the power, and we're doing it from 3 to 2. So this would be a definite, don't use the word definite. This would be something you absolutely have to show that as part of the working out. Okay. Then we start subbing in 3 squared over 3, 2 squared over 3, 19 over 3. So if you look at this is from 3 to 2, and this is from 2 to 3, x squared and x squared. So some of you might already make a guess about what this answer is going to be. Let's do it anyway. So obviously add a power, divide by the power. 2 squared over 3, 3 squared over 3, minus 19 over 3. So I'm sure some of you are going, oh, it's just going to be the negative answer, isn't it? And this one here, we have to do it in different bits. So we've added a power and divided by that power. Don't forget, when we divide by 3 over 2, that's the same as times in by 2 over 3. Add a power, divide by that power. I'm doing it from 1 to 0. So a bit of a shortcut here, because if we do 0 to the power of that, 0 to that, it's going to be 0, isn't it? So really, we only have to work it out with the 1 here. We don't have to worry about that bit. So it's just 1 to the power of that is just 1. 1 to the power of that was 1. So it's just 2/3 plus 2/5. 16. Okay, and of course, we're going to have to do annoying things with exponentials, and that one looks like it might have a log in it and all that sort of stuff. So here's our notation. So we've got our rule. So that obviously comes down to the bottom, and it goes from 1 to 0. That's a minus 1. Now here, of course, we do need to use the 0 here because e to the power of 0 is 1. So take care. In the previous example, we didn't need to worry about the 0. Here we do. So just give it some thought all the time. So we got that. Looks like it's going to be minus 2e. So e to the minus 2. That's just going to be 1, and because we've got a 1 outside, we can probably just change these two around. So 1 minus e to the minus 2. Obviously, we could do that as a fraction and take it down to the bottom, but because it's given in the form of a minus, we can probably leave it like that. This one here, so log base e, so it's a half log base e of 2x minus 5, and we're going from 5 to 4. So it's a half log e of 5 minus log e of 3. So an x is 5, 2 times 5 is 10, take away 5 is 5. 4, 2 times 4 is 8, take away 5 is 3. So log rules, we've taken away there, we divide, so it's a half natural log 5 over 3. We could probably leave it like that. Or of course, we can get rid of that half and probably make that a negative. So lots and lots and lots of sort of like notes there, but a lot of it will just be common sense. And as you do the questions, you'll start to realize what these mean. We've talked about them always. So it's just saying if you're working out the integral from b to a, and you've got sort of a midpoint in there. Here it's just saying that if you're going from, if you're working out the area from a to a, it's always going to be 0. Take that k outside. F and g, you can split them up, so you can say it's the integral of f plus or minus the integral of g. And this is one that we saw before. If you're going from b to a, it's just the same as minus a to b. Another question for you to do. It does get a bit tricky, this question. So the first part is kind of on working out the definite interval, but parts B and C get a little bit tricky. But I reckon you can have a go at it. Good luck anyway.